In nuclear medicine, small doses of radioactive material are given to the patient, usually through injection through the bloodstream, inhalation or oral digestion, and this process is called radiopharmaceutical. Radioactive materials are elements that have more than an atomic number of 83 because the strong nuclear force cannot overcome the coulombic force. Since there are always more protons than neutrons, thus making the nucleus unstable. In order to stabilize the nucleus, it undergoes alpha or beta decay depending on the element. Elements that go to alpha decay usually contain too many nuclei, and by ejecting 2 protons and 2 neutrons from the parent nucleus, which is the origin nucleus, as a result, a new element is formed that's 2 places lower from the periodic table, which is called the daughter nucleus, and also the ejected protons and neutrons form a helium nucleus or an alpha particle. In beta decay, there are 2 processes that can make the nuclei more stable. Beta plus and beta minus decay. In beta plus, a proton is converted into a neutron and eject a positron. And inject a proton, and in beta minus, a neutron turns into a proton and eject an electron. Beta plus and beta minus are usually accompanied by the release of small amount of energy in the form of gamma rays. And there are many special cameras. Cameras and imaging device to scan and detect the release of the gamma ray. But the most well-known one in nuclear medicine are single photon compute tomography or SPECT and positron emission tomography PET. These devices is what make nuclear medicine unique, as it provides 3-dimensional image of the distribution of radioactive tracer molecules that have been introduced into the patient's body. To put it simply, the device are able to detect gamma ray and use that to create an image of the inside of the body, hence helping doctors to gain valuable information. Iodine was discovered by Barlow-Cortes in 1811 while extracting potassium and sodium from seaweed ash. Iodine is a chemical element in the periodic table that has an atomic number of 53 with a symbol of I, and it is the heaviest of the stable hydrogen. Iodine is an essential element in our daily life as it provides thyroid hormones production, which regulates our weight, energy level, temperature, hair, nail growth, and more. Iodine 123 is the radioactive isotope of iodine. It is produced in a craton, which is a particle accelerator that was invented by Ernest Lorentz. In the craton, iodine is produced when it is bombarded with enriched uranium-124, where the enriched uranium-124 absorbs the protons and immediately lose a neutron to form uranium-123. And or it loses two neutrons to form calcium 123, which decays to xenon 123. This is good because xenon 123 can be refrigerated and be stored, and xenon 123 decays down to iodine 123. So they're basically the same thing, but it goes down as it goes down. There are many ways iodine 123 is used in medicine, such as nuclear medicine, medical imaging, and disease such as cancer. But it is most used in the diagnosing for the study of thyroid disease, because the benefit of using iodine 123 outweighs the disadvantage of using it, such as being pregnant or feeding women can't use it. The benefit of using iodine 123 is that it releases 159 Kelvin volts, I guess, which is ideal for scanning of the imaging device for PETs and SPECT. Furthermore, iodine 123 has a half-life of only 13.22 hours, which means it will take 13.22 hours to decay down to half of its original radiation. And it also causes less harm to the thyroid tissue and cells. For example, R9123 is used in thyroid cancer such as hypothyroidism and hyperthyroidism, which the patient would digest R9123 after 6 to 24 hours. The gamma radiation released by the decay of R9123 are picked up by a gamma camera, which uses this radiation to create a picture of the thyroid glands, which they can't see using like normal cameras. In conclusion, Anna is pretty good and it's the top of its game.
Would anyone like to ask any questions?
Any questions?
Oh.
Any questions?
No? All right, fantastic.